It's an incredible pleasure to welcome the Living Architecture Systems Group Symposium of 2019 here to OCAD University. Equally, Philip is a wonderful personal colleague and a friend and a partner of our institution. And we're very pleased to host and, in fact, sponsor you today and over the next few days here. It's so interesting to think back on history, and I know we're going to be really privileged to have an opportunity to do that tonight, and I'll give a more formal introduction. A number of us have been, over the last few decades, immersed in these conversations about, the sort of boundaries between what are life forms, what is consciousness, how do we understand matter and materials as they're changing, and these questions are so critically important as we think about the future of our cities, we think about health, we think about identity, we think about power, and we think about government. So there's a kind of politics to these dialogues that have been emergent side by side with the practices, the experimentation, the tests, and the emergences that are underway. A number of us, and I know my colleague, and I just have to make a shout out to him, Dr. Douglas McLeod is here, currently at Athabasca University, but when I was just starting at the Banff Center, where I founded the Banff New Media Institute. I was there for many years. Doug was leading the most amazing set of projects that were exploring virtual reality in the early 1990s from a creative and artistic as well as computational perspective. And those dialogues were already looking at these difficult sorts of architectures, the architectures of computation and the architectures of the body in immersive space. And again, what are those interfaces? And the Banff Center, and Philip was very engaged with us there, and a number of others of you were as well, was a site of that kind of experimentation. And I think it's really critical, and I will start my formal remarks in a minute, that we bring together, this capacity to really work through the humanities and philosophy and social science and ethnography, as well as architecture and engineering and the biological sciences, and of course, and this is the largest art and design school in the country, the arts, to really solve this kind of nexus. Xiaojin Wei is here as well, another colleague who was very present at Banff. So I now want to step forward and acknowledge the ancestral and traditional territories of the Mississauga, of the Credit, the Haudenosaunee, the Huron-Wendat, and the Anishinaabe, who are the original owners and custodians of the land on which we stand it and we create. This acknowledgement is particularly relevant to this wonderful conference. While they are distinct from one another, many Indigenous communities espouse a holistic and integrated view of science, technology, and culture, with cultural expressions operating as a means to observe, uncover, and express scientific discovery. In considering artificial intelligence, artificial life, these sort of transfigurative materials and living systems, it is valuable to acknowledge that non-human agency has deep cultural roots outside of the Western imaginary. Indigenous philosophers have refused to separate the animate from the inanimate world. They do so in language, but it is always in a kind of valent interaction. The present from the past and future, and the visible from the invisible. Drawing from place, story, and protocol, language expert Shirley Williams translates the term bimadazi to mean he, she is living, and bimadazawen as an abstract noun meaning the art of living life. An artist and cultural theorist, Jackson Two Bears, writes that Indigenous people, and I'll quote, often understand technology as something alive and filled with spirit, something with which we are interconnected, and I end the quote. So this idea of a living network is comprised of, and I quote him again, obviously living things like animals and plants, but equally as seemingly inanimate things like mountains, rivers, and human-made artifacts, unquote. These are some helpful frames as we look back to history and forward to its interpretation tonight. Last year was the 50th anniversary of cybernetic serendipity, an exhibition that articulated the interaction of the arts and sciences and set the stage for many years of complex engagement. And I've recently reflected on this. I was one of the speakers there to really try and look at how the kind of interest in what we now call STEAM, or the integration of arts and science, needs to have more of a kind of globalist, not only a kind of Western perspective as we move forward. So now it is with great pleasure that I introduce Paul Pangaro, the professor of the practice in the Human-Computer Interaction Institute, Carnegie Mellon University in Pittsburgh. Tonight, Paul will share reflections on the work of Gordon Pask and its relevance today. So looking back to look forward. And Paul has been designing conversational interfaces for 40 years, though not, as he says, the ones of today, such as Alexa and Siri, and I'm quoting him. He, of course, went to MIT. He received a Bachelor's of Science in Human Computer Science, and then was hired by Nicholas Negroponte onto the research staff of the MIT Architecture Machine Group, the predecessor of the Media Lab. That's there, and I think you'll hear this story tonight, where he met Gordon Pask, and he worked with him to earn his PhD in cybernetics at Brunel University in the UK. I think what's so important too, and again, if we think about the sort of indigenous conversation, it's that history isn't linear, it's not always progressive. We need to think back to think forward. To really understand, the worlds that we're in. So it's with great pleasure that I asked Paul to share his very brilliant thoughts with us, and I know we'll have a great conversation afterwards. Thank you so much for being here.
So I want to thank Philip and Melanie and Sasha and Sarah, of course, for the wonderful introduction, for the opportunity to be with you this evening. There's a lot to say, and a lot of ideas to go with here, so I think I should dive in. You get the point. We need less interference. And if you look at the word interfere, it's a fascinating word of its own. In fact, it comes from an old French word meaning to strike blows at one another, to interfere. And if you look at these words, they're all kind of scary, and you see how many there are? There are lots of ways, too many ways, for the technology to interfere. And there's one argument I'd like to make, which is because it's interfering so much, we're not exercising this thing that as human beings we do, and we need to do, which is to connect, to have a relationship socially in this kind of exchange. Whether it's in real time or not, whether it's face-to-face or not, we're losing that because we're getting distracted. Because all of these ways of getting content coming at us, all of these social media systems that are not bringing us social media, they're bringing us a deluge. And there's a phrase that a colleague of mine has coined recently, which is because we're not exercising this very important muscle of the brain, the social muscle, the thing that keeps us human, is we end up having a problem that he calls, whoops, we have to interfere with it once more. I should use the clicker. Instead, we have a problem of obesity of the brain. Think about that for a minute. I think it's literally true that when we lack the human connection and when we lack the practice of being connected, we get obesity of the brain. The muscle loses its capacity to know what to do. And of course, if you're following the problems with the younger generations who are having issues, one says, at least in terms of the psychology of it all, they're more depressed, they're less likely to want to talk to one another. It could be connected to this. Another common phrase is interface, which is a wonderful word, right? It's about the face. I'd like to have it more prominent as a face, as you know, given how I started out. So what do we do? Oh my God, look at all of those ways of thinking about interface. Isn't it fantastic? Such a rich vocabulary for having faces between us instead of strikes or blows between us. Melt into. It's a beautiful one. So that was an opening comment. Now I'd like to give a case history. Imagine that it's 50 years ago, and you enter the exhibition called Cybernetic Serendipity, and you see this. What the hell is that? It's as if it's fallen, fully made from the sky. It seems to be some things hanging. By the way, this is not related to Gordon Pask's Colloquy of Mobiles. This is a robotish kind of thing by Nicholas Schurfer, a name you should know. The graphics in the back are not related. This is a panel hanging which has been lost to posterity that is some kind of description of the colloquy. And the rest of it are these mobiles. Here's a shape on the left, may remind you of Venus of Willendorf. Do you know this reference? Yes, I'm getting some yeses. And the shape on the right, this black thing, which we'll come back to. It fell to Earth without warning, and it was available for playing with, watching the mobiles interact with the mobiles. I'll explain that more in a moment. And people could walk in the audience, could walk through it, and interact with it as well. These are various views of it. So where did this thing come from? Well, no surprise, it came from Gordon Pask. Here he is standing in front of one of the mobiles that he designed. He designed these so-called male mobiles. I don't know what was in his head when he designed them, but one would enjoy guessing, I think. This is Yolanda Sonnabend, who is a very highly regarded designer for the Royal Ballet, costumes, productions, staging. And she also was involved to design the female mobiles. So knowing the history of art, Venus of Willendorf, one might expect that. And I said to Jaja Reichart, who was the original curator of the entire exhibition, Cybernetic Serendipity, how did Yolanda Sonnabend know Gordon Pask? And she wrote back this slightly choppy email response saying, she knew everyone. She was interested in scientists. So of course, she went all the time to the National Philosophical Society and so on. So I felt reprimanded for not assuming that she would know all of the scientists. This is the poster from the original show. It ran for 11 weeks, 60,000 visitors at the ICA, the Institute for Contemporary Arts in London. And Jaja Reichart was 27 years old when she did this. And it was indeed the idea that scientists and engineers and artists would all come together without distinction. She makes the point very clearly that they didn't say, oh, this was done by an artist, oh, this was done by a scientist. And I think that was an important part of it. Some other shots from the exhibition. Again, one of the robots in the dark there. This thing here in the front is an organic form. That was one of the responsive systems, which when you spoke to it, craned over, sort of turned toward you as a responsive thing, reactive thing. But we're here to focus on this. This little area here that I'm shading in puce, Gordon's favorite color, is the electronics. You can see how big it is. And this is the replica that we went to some trouble to make recently when I was chair of an interaction design department at the College for Creative Studies in Detroit. This is the original that you've seen a moment ago, and here's how it looked. Here are some other gallery shots. An immersive experience, an organic, sensual, analog experience. Some of the shots from the exhibition, the exhibit, I should say. Now let me try to explain how it worked. So this is a so-called male mobile, which is flashing its light. It's a message. If the message hits a receptive female, the female will stop its pivoting, will respond with a sound, and then if the male hears the sound from the female, it stops flashing its light, it makes the light go constantly, and as the light flashes on the sensors down below, the drive is satisfied. I'm not responsible for the metaphor. I'm not responsible for the metaphor, but this is how it goes. I mean, the idea of a male whose light shines, you know, think about it. As I said, the beauty of it is that you can have people in the audience also interacting with flashlights, interposing themselves. There was a gentleman whom I knew personally who said that he came upon this exhibition in surprise, and he spent hours and hours playing with it, and at the end, he wanted to know who had made it. And as a consequence of meeting Gordon Pask, he funded Pask for well over a decade, and he funded me and others. His name was Joe Zeidner. He was a psychologist in the Army Research Institute, which he ran for a while. And he became so fascinated by the idea that he couldn't help himself, and he funded Gordon for many, many years. Now, what's the purpose of all this? Actually, before I tell you about the purpose, let's talk about what we had to do to make it. This is a flowchart in Gordon's own hand, talking about what the female would do. Also, there was a publication edited by Aja Reichart, which came years after the exhibition itself, in which Gordon wrote a paper called A Comment, which is about novelty. I recommend it to all of you. A case history, which is a discussion of music color that I'll get back to, and a plan. And the plan was the music color that would be built. Here's a diagram from that article, which shows you the geometry, and we thought, wow, this is great. We can just make this thing, right? Sorry. I should use this clicker. It's more reliable. Here's a description of how it's supposed to work. It is evident that the achievement of the O satisfaction goal involves, et cetera, et cetera, et cetera. There were a couple of black and white movies, which were not very easy to see, but which nonetheless gave you a sense of how the original operated, what its behaviors were. I won't dwell on this. That's a master shot. This is a close-up. 50 years ago, this is what it looked like. I mean, imagine walking into a gallery 50 years ago and seeing this crazy thing. And remember, it's machines talking to machines. We have that every day now, and we're not surprised. But the idea of creating an environment in which that would be true must have been madness.
Not restricted by any means to use in the classroom or several places like that. That is a machinery, hardly discernible perhaps, for running a colloquy of mobiles, as it was called. That's the wrong way up, yes. These were large suspended mobiles, and I was taxed with the ability of making an exhibition piece for entertainment, in fact, with which people would engage in conversations through. So I made a family of mobiles, which were these things, on a mechanically rotatable beams, an environment out of a PDP-8 computer, a small one, and what in those days would be equivalent to a microprocessor, a load of junk in each one. Point being that the mobiles had a little life of their own, and they chatted to each other by beams of light, which they waggled up and down, and by hooting sound and so forth, and anybody could go into that discourse if they wanted to and hoot at them or put their hand up in front of the light. And they did.
So what's the point? The point is that he managed to get an engagement with these crazy, wacky things made out of mostly analog equipment that was the size of 2 small bins. I want to whip very, very quickly through the process of making it, because there are so many makers in the audience here that I think it's worth a minute or two. So this is T.J. McLeish. This is the reason why I even started this project. He was the master fabricator of it. He worked with the students. There were 2 classes. We began by characterizing what all the pieces were. And we looked at this diagram from Pask, and we said, great, we're going to follow that diagram. Well, of course, the diagram's wrong, right? The diagram is simply wrong, and it's wrong in a number of ways. First of all, the geometry is different. It's actually an equilateral triangle. And the sensors and hanging things on the bottom of the male mobiles are different. And it was the first of many shocks, particularly to the students who thought it was going to be a straight line from reading the history and making the thing. So here's a description of what goes on. Consider a female. She has an O drive and a P drive, standing for orange and puce, by the way, in case you think it's something more nefarious than that. 2 of his favorite colors. And so the students went through this material, and they created diagrams which captured what the hell the thing did, or at least insofar as we could interpret it. And they were very frustrated when they found contradictions. They had trouble with that, which is fascinating. They also simulated how it worked 50 years ago, and at the same time they were invited to invent how it could work today. And the first new scenario that they invented, because they thought there was an imbalance between the so-called males and the so-called females, was they created what they called revenge mode, in which the females had a fully equal part and then ultimately an upper hand on what was going on. So there's much more of that. They extracted the simplified expressions on the right, which were almost pseudocode, and this was the nature of trying to understand the behaviors. That was one course in the program that I had chaired for some years. The other course built a scale model. This is the professor who worked on making it come alive. And they built this little thing, and it didn't do everything that the real thing did, but here it is. So the male's light is going to touch the female's sensor. The female stops. It begins its mirror waggle. And then right away it gets bored and keeps going. Well, how did the females get made? We looked at all of the photographic record. T.J. McLeish took all the photographs available and extracted a 3D model. This looked like this. We made a small 3D printed version. And in simulation, it looked like this. Now, one of the people at the college, by the way, it was a slog to get them to let us build this thing. I'll tell you the story over a drink sometime. And they said, well, why don't you just simulate it, right? You've got all the details. And, you know, that's back to the interference idea. Unless you make it and you can walk through it, you don't really understand what it is. Here's another simulation. Here's looking at different ways of fabricating it. Here's a process of taking a 3D model, printing paper forms, making a matrix in 3D, filling it with foam, shaving it, shaving it down, even better, beautiful close-ups, wrapping it in cellophane, coating it in resin, and then this is what you get. So they took the 3D models that TJ had made, and this fabrication place in Chicago did it for us. TJ also designed the structure, ways to hang the mobiles, ways to rotate the males, 3D printing for gears to run the stepper motors, and here we are putting it together. Students had a blast. The ceiling did not fall, as the administration had been worried. And TJ did all the design. He designed the electronics. He picked out the pieces that we bought off the shelf. He designed the gearing. Students helped doing some testing. Here's what went inside the females to waggle the mirrors. He designed the printed circuit boards. He did all the software. He put it together with some help of the students. And there we are. We had a documentation workshop. This extraordinary designer, Bruce McIntosh, a longtime friend, came and worked with the students, produced many artifacts, including a website, which I invite you to see. We had public exhibitions. We claimed in these 3 bullets that it was important for the future and not just for the past. Somebody said to me, I won't tell you who, when this idea first came up, he said, why would you want to make something that was 50 years old? I still can't say that and imagine that somebody really said it, but it's true. Why would you want to make something that was done 50 years ago? I don't think I have to explain that to you, but it was another barrier. We had wonderful press in Hyperallergic and other places, and of course, after about 6 months of run, we had to mothball it. So it's sitting, waiting for a new home. We've had inquiries from well-known media, arts and media museum in Germany, also one in Paris, one in China, and we're still trying to figure out how we can make some crates, raise the money, and ship it. You've been very patient. Where did it come from? Where did PASC take it? And what should we do from here? In some ways, I feel bad dragging you through this because we have a long way to go, but if PASC were here, he'd be at it for 2 hours, and he would not let you go. So I only have an hour. So I hope that's okay, and of course I am not, clearly not Gordon PASC. But I want to give you a taste. So interaction, of course, would be a place to start. But saying that Pask built interaction machines is really an impoverished way of saying it. He built conversing machines. And I'm not going to give you a list of words that come out of the thesaurus about conversing, because you need to see the man himself. So I'm going to give you a little bit of a timeline and use colloquy as a kind of pivot point. And I want to talk very quickly about 3 of his machines, because from those machines I want to extract some principles which I think relate to so much of what we've talked about today, and I hope is valuable to the community at large. This music color thing, he took around England with his fiancée and subsequent wife, Elizabeth Pask, and Bobby McKinnon Wood, both of whom I know, all of whom I knew. And he would install it in dance halls. And it was a piece of equipment that looked like this. You can tell that it's really the back view because the meters match. And here's a view of another one. Apparently it blew up a lot, caught fire. This is a true story. But what was music color? It was somebody playing at a keyboard, or perhaps dancing, he also talked about. Going into the machine, the mechanics of it. It reacts with light, and the light closes the loop by being seen by the performer, who then reacts. Now, what the hell was going on? This takes a moment of description. Imagine someone playing improvisationally in a particular range in the keyboard, let's say C to, middle C to C above C. And they're playing. And first the machine calibrates itself so that it's showing some light, because if somebody's playing very quietly, then you want it to do something. And if somebody's playing really loud, then you don't want it to be pegged with all the lights on. So there's a Hunter circuit to adjust. But from there it gets interesting, and I heard the word here today, so this is probably not unknown to many of you. It got bored. It stopped responding. So if you're playing and the damn thing stops responding, what do? You say, oh, it stops responding. And you play around until it responds again. Now, it did this in 5 different dimensions because it had 5 lights. It also had a rhythm thing, which I don't have time to describe. So it not only had this initial loop circuit of adjusting so that it was always responding to you to some extent, but it had this second order loop of boredom. So what was it doing? And I want to begin to extract some principles. It was trying to regulate the novelty of what it was showing you. It detects repetition, gets bored, and changes its responsiveness in order to maintain engagement. Okay? Novelty, regulation. This happens in conversation. If I started repeating myself, you'd stop listening. If I started repeating, I'm sorry. Right? I mean, we stop listening when people get repetitious. Second machine he built was called Saki, the self-adaptive keyboard instructor. Now, I also want to say a few things about the technology. So you see this area here. This is a piece of film strip which has letters on it, which tells the person what to type, because it's going to help the person learn how to type. This is a giant piece of metal that is in this picture on the upper part. So that's one example in 3 views. So you're telling the machine what the exercise is with a piece of plastic. You also have to tell it, you, the maker, what the letters are that you want the person to type. So this little boxy thing with a giant knob that weighed many pounds that you had to push in and screw in was 128 bytes of information, which told the machine the letters that were on the strip. So don't ever tell me you don't have the technology to do something. I refuse to accept it. What I will say in return is, no, you don't have the idea yet. Because if you have the idea, you can make it. You can make some form of it. And there'll be another example of this. So here we are again. This was later when we tried to make one that ran in a mini computer, sorry, a purpose-built microcomputer. And then we also built some software. So what is Saki doing? How does it work? What it does is it presents an exercise to you, and if it's something that you're doing well at, it makes it harder. But if it makes it too hard and you begin to fail at it, then it simplifies. So it's constantly looking for the sweet spot in the middle. So another word for this is that it's regulating your uncertainty. how much new is this thing that you're giving it, and can it be regulated? So it senses your facility, how well you're doing something, and your failure, how poorly you're doing something. And it calculates, it actually diagnoses what your problem is and gives you the right subproblem to keep going. I have a few more examples. This is a machine talking to a machine. The left side and the right side are pupil and teacher. And it also implemented multi-layers. As it turns out, this damn thing ran a neural net in the early mid-50s. And it had a panel on it, which I still possess, that I want to talk about for a second, because it just blows my mind. So this is from the pupil computer, right? And look at what you can control in the pupil computer. You can control its internal awareness. You can control its external awareness. And you can also control its obstinacy. I got one better than that. Here's this thing called oblivescence. Think of the word oblivious. Took me a while to find a dictionary that had the definition. A machine talking to a machine, pretending to be a pupil and a teacher. So what's the principle here? Well, this thing was called Eucrates, which comes from a reference to Plato's writing. It's operating at multiple levels of feedback, engaging in conversation, and maintaining individualized goals. So that's that. Cybernetic theater. I can't be here and not show you this. This was a proposals, plural, for a cybernetic theater. Here he says, hey, you got people in real time in a theater. Why the hell are you going to pretend that it's like a TV or a radio show? Let's do something dynamic. Here's a design for the electronics. Here's the board backstage of sort of the stage manager who sees how the audience is voting on a real-time basis. And what they can do, what every individual in the audience can do, can say, I want to go with A or I want to go with B. These are characters in the play. And here's where you choose that, so that at the very top there are switches. And you say, if you want to go with A, what happens is you hear in your earphone a meta conversation about what's going on inside the character's head. Now, that had to be recorded ahead of time, although he speculates on other ways of doing it. So interactive theater, many years ago, instrumented and proposed right here, 1964. Guess what? It has the same architecture. Okay. So that's where colloquy came from. Colloquy came next, and it was about multi-layers of feedback inside of a machine. Where did he go from here? Let's try this.
Thing, giving, say, two explanations at once, will be represented by putting a marker of some sort on some of these and saying, we're dealing with conversations as the things we study. We're not much interested in what the conversation is about. We're interested in how it takes place. And the hypotheses we test are about how people understand or learn, or what can be known and can't be about processes in conversations. I mean, somebody with the wit and the guts to go and do and create. And that, I believe, is what education is all about.
Amazing, huh? That's the way he was. He was just incredibly intense and playful and performative. He wrote a couple of books around this time. I don't know how you write 2 books of that weight within 2 years, but a lot of it was research he had done before. He was also scribbling out the idea that became the core rigorous thoughts of conversation theory. This is in his hand. Notice the cigarette burn, very important. And this led to a couple of systems, ThoughtSticker and the architecture machine. This is ThoughtSticker that he built in his laboratory, a very damp basement in a very old Edwardian building in Richmond. I remember it well. There's a mini computer there that had 8-inch floppy disks that could not hold the material that you wanted to show a student in the experiment. Too much text wouldn't fit, needed it for program. So what did he do? He built these cubby holes, and there was an LED light on top of each cubby hole, such that if you wanted the student to read something, the LED light went on, and you pull out a clipboard which has a piece of paper of what to read. Don't tell me you don't have the technology to do what you want. It's not as powerful now as it used to be. One could talk about this 10 years ago and you'd believe it. Now we think that the technology is always there, but I think it's extraordinary that he managed to do this. Around this time, Nicholas Negroponte, as Sarah said in the opening, had a place at MIT called the Architecture Machine Group. And he had published a paper and a book called The Architecture Machine. And then he published a set of chapters where Pask wrote the first chapter, which was Aspects of Machine Intelligence. And Pask had done these diagrams with the intention that Negroponte would take them and give them to a graphic designer and render them prettily. Nicholas was too smart for that, and he just reproduced them. He drew some heavy lines to make an emphasis, which have since faded from the originals. Now, I ask your indulgence for a minute. I'm going to do it a few more times, and I know you're tired, but I'll try to go quickly. This is his whole theory of interaction as conversation. Interactions occur through an interface. You damn well better have an interface or you don't know what the hell's going on. They take place between participants. These interactions can be noted by an observer as sometimes being about goals and sometimes being about ways to achieve the goals or means. This is 2 layers. It'll be a repeating theme. Now, these are processes. They're not static things that get pulled from a database. They're ongoing active processes which are being dynamically computed. And in a single individual, you might have a conversation taking place. So internal to my head, I'm thinking, gee, how's it going? Well, not too bad, but it was terrible the way the technology didn't work. Yeah, but you're doing okay. I don't know, I'm kind of thirsty, right? You do this all the time. This is an internal conversation. He always wanted to emphasize that that was happening and had the same structure as a conversation between me and you. This is one of his contributions. Another thing important to the diagram is that there's an environment out there, there's a real world that gets touched by the consequence of deciding individually or together that we're going to take actions. And then here is a design for an architecture machine in which the computer and the human engage in conversation, sometimes about the goals, sometimes about the means to achieve the goals, and therefore the machine is a co-designer, a co-participant. The machine's not just doing the CAD drawings and how thick the beams have to be, or showing you renderings. This is a full-fledged architecture machine. This was the proposal of Pask in the context of the architecture machine, which, by the way, was left behind when Nicholas jumped to make the Media Lab with a different set of values and a different set of interests. But here's this fourth idea, which is, wouldn't it be good if we can make computers have conversations with people where the machine co-participates in the definition of the goals as well as the definition of the means? This is his final diagram. I wish I had a lot of time to go through this. This is a diagram in which I use you as an extension of myself and you use me as an extension of yourself, such that we're going back and forth in this looping and we're losing the distinction between us in the conversation, and we're having a flow. Another way of looking at it is as formal feedback loops, or as I've been showing you along the way, these things. So this is the architecture machine. So these are 4 interaction principles that I think are good to have around. I was thinking of these a bit when I saw a lot of the presentations today. Reactive systems, systems where we have to decide what it's going to do and how it will do it and what will be interesting and so on. I think there are some hints here which I offer you. So that's where Pask took colloquy into the conversation theory work. He did later work as well, but this is where I'll end the story about him. One place to take it is to reinterpret. This was a series of spreads, this is a series of spreads, from a project done by Karen Bernson, who's a colleague of mine now at Carnegie Mellon, where she presented the students with the output of the colloquy project. It's a massive array of history and some of the pictures I've shown you in its construction. And each of them, there were 20 of them, I'm only showing you 3, took a different turn on it. The first took it as a project to make something. This student took it as a history of important people working on it. Talks about cybernetic serendipity. Forgive me for going quickly, but in the interest of time. So taking it into the future might mean reinterpreting it. Here's a student who took it in a very different direction, not the only one, which was to ask the question, what does this mean in terms of gender interactions? What did PASC mean 50 years ago? How do we interpret it differently today? What does it mean? And a lot of the conversations we had at College for Creative Studies were about this issue. But the main contribution, I think, is always, why does conversation matter? We have to agree if we're going to act together. To reach agreement, we have to have an exchange. And to hold an exchange, we have to have shared language. This is a foundation of the diagrams I showed you. What comes from conversation? The unity thing, that's expressed in the diagram, the last one that I did this about. We don't mind if you do something to me that is a little bit strong, because I know that I trust you and we have a common goal, so I might do it back to you. Think of a tango. Think of a dance in which you shove me and I go, whoa, that was kind of rough. And then I realize, oh, the purpose is to have a dance. And so I shove back. Shove's a little strong, but I think you know what I mean. This back and forth. What do we get from conversation? Feels awfully important to me. So this is this dance of shared creativity. This is his handwriting. This is my translation. I'm sorry, it's not a translation, transcription. The translation would be involved in actually going through the details and talking about it, which I'd be happy to do. It'll show you that there's a mistake in the diagram. I brought it to Gordon one day. He says, yeah. I mean, it's obvious. It's not magic that I could look at it. Now, I'd like to go a little bit into some of the work that I have derived from PASC. This is part of what I was asked to do. And then we're almost done. I came across Gordon when I was at the Architecture Machine, and I'd been steeped in AI, and I had taken all the courses that Minsky and Papert had, and I was never quite satisfied with the AI thing. And Gordon walked in one day, and I said, what he has, I want that, because there was a humanism to his approach to these things. Very cerebral, yes, very abstract, yes, but it felt right. There was a resonance of his models to my experience. I don't get that resonance with AI. So this embarked me on a journey, which I now cast in terms of what I would like from my technology. This is good conversation. Will we get that? I don't know, maybe. What's great conversation? It's about delight and energy and going places that you can't go on your own. Will we get that? Maybe. What's a great conversational partner? These things. Helps you be what you want to be or to become because you don't know what's possible yet. So, knowing his work and starting from ThoughtSticker, I'd like to present a couple of other pieces that derive from it. This is the crufty thing that was my PhD thesis, or at least the software part. This is a version. So this became this. Not at all analog. But it also became this. This was a system called Thought Shuffler. This works like Thought Sticker. It has something inside it that has an uncertainty regulator. And imagine trying to do search with your search terms over there that you can turn on and off in blue, and that changing the priority, Thought Shuffler, right? It's a lot of fun. Built it with some money from a Brazilian guy who was interested in conversation for enterprise stuff. Very complicated. People said, wow, that's really good for researchers. But we tried to rewrite it to become this. The thing I'm most proud of is this. So you're on the phone, and you type in National Geographic and fracking. This was done for National Geographic, by the way. So it goes to the web, it adds the white terms as relevant, and it brings you individual paragraphs based on who you are and what would be novel for you. You can read the whole thing if you want, but it still shows you the blue bits, which it feels is the most important thing to show you now. And so it does a search for you, but compartmentalizes the results bit by bit. But the other thing it can do is it can change the context. So I typed in the black terms, and it's proposing the white terms. So it's capsulizing a kind of cluster of idea, or a concept, as Pask would call it, and changing. You can also look directly at the clusters, and you can navigate through the clusters. Uncertainty regulation, novelty, not quite a conversation for a machine. This was shown to Condé Nast and to the New York Times, and they said, how much money can you make me if I put this on the homepage? So that was the end of that conversation. And here was another attempt. I'm just trying to show you different manifestations of the same idea of an uncertainty regulation and a conversation with content. But that's not the only thing you can do with Pask. You don't have to write software or build machines. You can have some other ideas that, again, I want to bring to you very quickly. I'd worked on a project with a guy at DuPont for a while, and then I was at Sun Microsystems, and we realized that both companies succeeded and failed. Sun hadn't quite failed, but it was clear it was going to, for the same reason, which is they create a language, a way of looking at the world, and that language is so good for letting them do what they do now that they can't see a change in the environment. Not that they see it and they say, that's not my business. They can't see it because they don't have a way of saying it. Think Bill Gates not getting the internet for a long time. He didn't have the language for it. He had a language for separating hardware for software and beating IBM and doing software applications that he would sell on diskettes, but he didn't understand the internet. So if an organization is its language, the way out of this trap is to regenerate by creating new language. This is conversation theory. It's Umberto Maturana. It's a bunch of things, but it's direct application. Another way is to say, we're designing something and we're great, and so we're just going to keep doing it. And that's the idea that you create a team to make something. The idea here is that you design the cadence of conversations, you don't design the team. So if you're familiar with the idea of variety from Ashby, then you design the variety in each successive conversation. This was more fun. This was the design of a poetry machine where you create an enactment layer of material between the reader, who has a biography and a local context, and the poem itself. And this is information about how to perform it, about the etymology of terms, and so on. And this is pure Pask. It's a way of creating a means of regulating the uncertainty of the reader as the reader is exposed to poetry. And last but not least is the idea of a design methodology based on conversation. So we've all heard about design thinking. And design thinking is whoops, wrong one. Sorry, gave it away. Come back. Design thinking is this box and this box implied, but not explicit enough to be useful. And I'm saying that you have to design conversations to create new language. You know why, because you don't want to get stuck in a language. And you need a conversation to design the designing. Anyway, it's a very modest, I hope, feeling to me proposing that there are other ways of thinking about conversation theory. So I had an opening comment about interference, and then this long case history. How do we get less interference, more dense? Well, I think we should start by declaring our intentions. So I think we need a cooperative interface, and we need to build more of these. So the interactions have to be coherent, they have to be understandable, they have to regulate the uncertainty so that they make sense to people. But they also have to enable participants to evolve their own point of view. I think that's essential. For the second idea, I have to engage you a little bit in what I call the parable of Luigi's Pizza. I need someone who's willing to ask me a question. Anyone willing? Would you mind asking me a question? Ask me where there's good pizza.
Where's there good pizza?
Luigi's, right across the street. Now ask me why is there good pizza there?
Why is there good pizza there?
Screw you, I'm not going to tell you why. I just described Google. This to me seems wrong. So the alternative is to build ethical interfaces. A conversation is an ethical interface when there's reliable transparency, why it's good, the reason why the algorithm chose, or to put it more properly, the heuristic, such that I can trust it over time. Because if you keep asking me questions and I never tell you why I'm giving you my answer, why should you trust me? Think Facebook. Now, you might say, well, of course, it's a proprietary algorithm, and they could tell you, but that would give something away. I don't care about that. You might also say that they could give you a list of the reasons that it uses, like terms and conditions, which nobody ever reads. So my claim is that this is inhumane, and a humane interface allows any participant to influence the direction of the conversation so that cooperation and collaboration may arise. So can we design for conversation? Can we enable conversation, interactions that wouldn't it be nice if instead of this thing in front of us, it was a conversation in which we could see who we wanted to be and who we might wish to become? Where do we look for help with that? Well, that's easy. We riff on Pask. So here are a couple of ideas, and then I truly am done. First of all, incorporate these ideas. This offer is already before you, but it's the first one to bring here. But I want to be more specific. I think we need a metric of conversationality. It's a little awkward. So we all know about the Turing test, right? So a Turing test is a person deciding whether a machine is intelligent. This metric is the idea that I can build an algorithm, have a machine decide if this human-to-human conversation is valuable. Not whether it's popular, not whether it's recent, not any reason why your news feed or your recommendation engine in Amazon or anything else algorithmically that's being presented to you. I want to calculate the relative quality of a conversation in terms of its novelty, momentum, and milestone agreements. Add your own evaluations there. I'm not set on these. To draw human attention. And let's put that into our social media feeds. I want that between my interface and me to tell me where to look. That would also prevent telling you the things that you already know, because it would have some sense of what's novel for you. And it would prevent telling you something that's from outer space that you would never understand. Another idea is a question engine. So we have answer engines, right? Google is an answer engine. It gives us answers. You know what the problem with that is? They're basing it on who I was a minute ago. They're basing it on what I've done before. So it's not about me now, it's about me before. Answers are dead. I'm alive. What would be something that I could have an interaction about now, that's about me now, that gives me the choice to do something new? Don't make all of the decisions based on who I was. Give me a new question. Give me a question that brings me somewhere I've never been before. But again, not something way over there, or not something so mundane that it's a repetition, but based on these Paskian ideas, compute new questions for me now so that I can be alive and so that I can become something that I'm not yet. You have to take it on faith that that's what this diagram is about. It's not specific about a question engine, but it's specific about the idea of dancing. It's specific about the idea that each of us can have an interaction with another based on trust, which requires history of conversation, based on wanting to go in the same direction, having similar values, not necessarily identical values, but values close enough for us to keep going and not to say, no, I'm not going there, or not to get bored, not to fall asleep. Something generative and engaging. Now, all of the demos I've shown you of my work have been about screens. And that's why this thing is so astounding, because it returns you to the fact that we are biology. We live in language, per Maturana, right? So can we make interfaces that are more organic and more like interacting? You guys do that, right? This is what you all do. So my offer, for what it's worth, you decide, is to take some of these ideas and to imagine how you might integrate them.
So how's this compare to playing with your iPhone? It's different, huh?
It's different than playing with your iPhone. So that is the story of less interference, more dance. Thank you very much.
Let me invite my dear esteemed colleague Omar Khan to come by way of acting as a moderator and to continue the conversation in the hope that he might be willing to moderate some questions and dialogue with you.
One question for me has always been about this question of environment. Cybernetics, and this starts maybe from Ashby's framing and also another character, Stafford Beer's framing of environment as what is outside us, but something that we're interacting with. But cybernetics has a closure piece, which I think is very interesting and important to talk about, this notion that we construct our environment as much as the environment constructs us. And I think it's worth noting because it has a lot to do with technology and how we think about it now.
Yeah, I think that is missing from a lot of the technologist conversation. One example is, oh, that's a smart machine, or that's a smart city. But cybernetics would say the interaction between this and that is smart or not. And the environment not only participates in how effective I am in doing what I want, I have to match to it and be cooperative. It's like a natural selection thing for survival. But also, if I don't respond to it, it'll kill me. Or it'll prevent me, at least, from doing the thing that I want to do. And so you have to be malleable and be willing to co-evolve. All evolution is co-evolution, even in biology, right? We don't think of it that way. So if you ignore the environment, you're losing everything in a sense, because you're losing the degree to which you can be responsible to be aware of this loop thing and to pay attention. And I was listening to Alan Watts the other day, who in the 60s says, well, you know, we're killing the environment. That was 50 years ago. That was 50 years ago. We didn't get that message yet, apparently, and it's because, from a Buddhist point of view, it's the unity, right? Yes, you can separate and you can say, well, this is black and this is white, but you can't have one without the other, in the same way that you can't have an organism interacting effectively without a recognition of the other side. So this would be the purely theoretical way of thinking about it. You might have a more interesting way of bringing that into your work, for example. Can you comment further on that?
Well, I think for me the interesting thing about that, this idea that, and this is actually some teaching that I'm doing right now, where we're looking at the Stafford Beer's VSM again, which is a model that he used for the basis for actually designing a whole political system of how industry would communicate with. This was for Chile's Allende government, which then was overthrown. But for me, what I think is very interesting is in this idea of that fundamentally it's a coupling that you could that it comes out of this idea of self-organization, that self-organization doesn't mean you organize yourself, but it is really organizing through that coupling.
Yes.
And I think that's always been very interesting to me, is to define that other. What is that other, whether it's the environment, whether it's you and I right now in conversation, and then you become an entity because of that coupling. Right.
It's that back and forth again.
All right.
So Heinz von Forster wrote a beautiful paper in which he says self-organization is not the self, but rather an exchange of entropy with an environment. The other point that's implied in everything there, particularly your opening question, I see the world based on how I see it, not on how it is. It may participate. We can be radical constructivists or another kind of constructivist. But the language that I bring to what I do is the way I see, and therefore the way I act. And I'm responsible for that. And it's interesting to tell designers this because they think, oh, there's a problem over there, I'm going to solve that problem. Well, you just made that up. There may be a consensus that that's a problem, but that isn't necessarily anything other than a social construct.
Do these interactions need to be literary? It strikes me that some of the things that you're eloquently articulating in your own work and in Pask's work relate to that a certain kind of literary kind of quality.
My particular work has been about the content because that's just something I was always interested in. But no, the diagram and the formalism is absolutely general and can apply to dancing, and it can apply to the creation of new language or semantics in the process of interacting. Maturana would say language arises as a consequence of interaction and not the other way around. And so our doing things and our using things are how we end up using symbols for those things, which then become a world of simulation and modeling all its own, in which we have these semantic and literary conversations. But there's nothing about his formalism that requires it to be this kind of spoken language or written language. It's rather any medium in which you can have this multi-layer thing. So I can do a dance in which I might propose something new that you realize is a new semantic idea, and you can respond to it if you wish. But that's you making up in your head what you think I mean. And that's a kind of conversation at the level of goal that doesn't say, now I'm going to turn left. Or now I want to create something that's more like an animal than a cloud. Right? So this distinction of level between goals and means is absolutely an amazing insight, this idea that there's an inner loop and an outer loop, and that one is controlling the goal of the other, and so on. This is where I think there's a very rich world, and it occurred to me multiple times in seeing the works today. So no, it does not have to be literary.
So I think we have just one more question left, because it's just getting quite late.
Paul, entirely delightful experience. Thank you so much. You know, I was thinking as you were speaking about what was happening in the U.S. to some extent during this time, which is all the work that Irving Goffman was doing in, you know, theorizing conversation from a sociological perspective. And he was also looking at the theater of discourse. You know, he was looking at roles and power and the exchange of conversation. So I'm very curious, and he was looking at affect within conversation, how, and also how it is about a kind of refusal of disclosure at the same time, right? So I'm curious about, was there an interaction at all between these ideas? Because they're timely and they overlap, and Goffman was in some ways thinking computationally. He actually tried to design some systems that looked at abstracting conversation and discourse.
I don't know for sure. I have a faint memory that Pask did talk about Goffman, but unfortunately it's not my province and I can't make the connection myself, so forgive me. But if you know something relevant, I'd like to
I think
hear
some
about
of
it and react to it.
I think some of the principles are interesting because you know, it's about power, right? And conversation is very much about the exchange of power, and it's about role and kind of positionality, right? So so I think that there's another dimension maybe to the way that you're thinking about this, and is very much about affect and the nuance of affect and how that plays out, that I think could add another piece to your work.
Thank you. And no question that these abstractions are flat. They're not thin, but they're flat. And taking this into it would be a wonderful way to deepen it and to make it richer, and also to connect it to that other heritage, which I would like to learn more about. Thank you.